I'm making this video as a supplement to assignment number 4 for 2 reasons. You need to watch the video so that you collect the data that you need to use to do the assignment. And the other reason is I would like to briefly walk you through what the graphical analysis is going to involve. What we're looking at is a refraction tank, and you have light refracting from air into an unknown liquid. The light originates in the top left corner of the refraction tank. It hits the interface between the air and the liquid, and it refracts towards the normal in the bottom right-hand corner. Just below the interface there is a dark band there. That's just a shadow. It's nothing to concern ourselves with. Remember that an angle of incidence is always measured between an incident beam and the normal line. The normal line in this example is the vertical line passing through the center of everything. An angle of refraction is always measured between a refracted beam and the normal line. So what I'm going to do is I'm going to choose angles of incidence that we're going to use. I'm going to use angles of incidence of 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, and 70 degrees. You have room in your assignment for 6 sets of data. So I'm going to go to 20 degrees right now for an angle of incidence, and your job is to record, of course, 20 degrees for the angle of incidence, but also to record the angle of refraction by reading the scale at the bottom as accurately as you can. I know that the scale is only incremented in 5-degree chunks, but unless it's right on 5 degrees or 10 degrees or 15 degrees, it's not 5 or 10 or 15 degrees. You have to estimate how many degrees it is to the nearest degree. All right, now I'm going to move on to 30 degrees. And if you need to, of course, you can pause the video. An angle of incidence of 40 degrees now. You want to determine the angle of refraction. An angle of incidence of 50 degrees. Again, you want to record the angle of refraction that you're observing. We are now at an angle of incidence of 60 degrees. This is our 5th data point. So our 6th data point would be at 70 degrees. So now you have all of your data. This is the data that you were going to use in assignment number 4. What I'm going to do now is walk through with you how you're going to analyze the data graphically. Okay, let me go through the graphical analysis with you right now. I want to write down our variables first. Theta 1 is what we call the manipulated variable. It was manipulated because I had an active role in deciding what it was. I said we were going to use 20 degrees and 30 degrees and 40 degrees. I made those decisions, so I manipulated the values of that variable. Theta 2, of course, was the responding variable. And we want to associate a manipulated variable with x. Be careful here, I'm not saying we're going to plot that on the horizontal axis. That won't work. And we always associate a responding variable with y. The reason why we can't just plot those variables on the axes is we won't get a straight line. The reason we don't get a straight line if we were to do that is because the formula that has theta 1 and theta 2 in it is more complicated than just having theta 1 and theta 2. It actually has a trigonometric ratio. Sine of theta 1 over sine of theta 2 equals n2 over n1. But we can simplify that formula because n1 is the index of refraction of the light in the air. The light in this experiment goes from air to that unknown liquid. By the way, everything I'm explaining here, it's an expectation that you explain in your analysis. In the end, we're going to come to a conclusion that to find n, you do something with the slope of your graph. But you have to explain why that's the case. So this becomes sine of theta 1 over sine of theta 2 equals n2, which is what we want to find. This is our goal. Now, when we plot a graph, we always want to rearrange the equation for the thing that's plotted on the vertical axis. Now, I said that theta 2 is associated with the vertical axis, which means that our y on the graph is going to have to be the sine of theta 2. That's our responding calculation. And x is going to have to be the sine of theta 1. If we rearrange this equation for sine of theta 2, which is our y coordinate, we're going to have sine of theta 1 over n2. Now, how does that help us? Well, we can rewrite that equation just slightly and write sine of theta 2 equals 1 over n2 multiplied by sine of theta 1. So I don't really want to finish your analysis for you, but I will tell you that you always compare your physics equation to y equals mx plus b, but we're not going to worry about that here. So I hope it's obvious that sine of theta 2 is your y, and sine of theta 1 is your x. So you should be able to figure out what to do with your slope to find the index of refraction. I hope that helps. You may have to watch it again and think about it again to really make it gel in your head, but I think that made sense. We'll talk to you guys later.